Good day, good peoples. This video is on chapter 8 continued with our confidence intervals. And so let's just jump right into it for example 7. The population for standard deviation for the age of Foothill College students is 15 years. If we want to be 95% confident that the sample mean is within 2 years of the true population mean age of the Foothill college students, how many randomly selected Foothill College students must be surveyed? So first things first, we want to, like we do in class, write down what we actually know. So what do we know? We know that our standard deviation is 15, right? We know that we're working with a confidence level of 95%. We know that, well, if we pay attention to the lingo right in here, it says the sample mean is within 2 years of the true mean population age. So this right here is an indication that this is our margin of error, right? Our margin of error, or in our OpenStax book, is calls it an EBM, right? So this EBM is going to equal to 2 because we are saying that we're 95% confident between 2 years of this population, right? But what we don't know is what we're trying to find out is how many randomly selected. So if we're looking for randomly selected, that means we're looking for N. We don't know what N is. So if you have read through the material, I go through and discuss exactly how to get our N through some algebraic process, right? So what we need to know is this formula right here, that N equals to Z squared times the standard deviation squared divided by that margin of error squared. So where Z is going to be that confidence level divided by 2, right? And so if we work through this, that means that we are going to have N equal to, well, we first have to find the Z, right? Let's talk about the Z first. So if I talk about the Z first, remember that has to be this alpha divided by 2. Yes, no, maybe so. So here we go. Remember the alpha, right, is really saying 1 minus the confidence level divided by 2, right? That's how we're really finding this piece of information. Okay, so this would be 1 minus 0.95 divided by 2, which would give me 0.05 divided by 2. So when we do 0.05 divided by 2 and we plug it into our GeoGebra, we end up seeing that our Z-score is this 1.9595. Okay, so with our Z now equaling to 1.96, just to have it on the shortcut, we can now plug it into our formula. So this should say that N is going to equal to 1.96 squared times, 15 squared divided by 2 squared. Now, if we plug this all into our calculator at one time, let's see. So let's turn it on. We are going to do parentheses 1.96 squared plus, not plus, times 15 squared, which should be 225, equal to that, and we will divide that by 2 squared, which is 4. So we end up getting 216.09 as our N. So therefore, since it's saying 216.09, we really would round that up to 217. Okay, so therefore we are saying 217 students should be surveyed in order to be 95% confident that we are within 2 years of the true mean aged population. So if we continue on with chapter 8, we move on to 8.2, which talks about students' t-distribution. So in previous sections, we have seen how to construct a confidence interval when the population standard deviation is known, right? But we rarely would know the value of our standard deviation while needing to estimate the value of our mean, right? So it is more common that our standard deviation is unknown. And when we don't know what the value of our standard deviation, we replace it with a sample standard deviation S, right? And so if we read through all of this, we discover all of these different types of terminology that I'm talking about through here. And then we even talk about a little bit of degrees of freedom and then the certain properties of the student's t-distribution that I told you guys that you need to read through so that I don't make this video very long. So with that being said, if we are saying that, again, a student t-distribution is symmetric, is unimodal. It is more spread out than a normal distribution. And if we increase the degrees of freedom, then the student's t-curve becomes closer and closer to this normal standard curve that is not exactly just it, right? We find the critical values roughly the same that way we would find it in a normal distribution. It looks very similar to a normal distribution, might I add as well. But we find it very similar to that, but we just call it a t critical value. So a couple of things we have with our assumptions. We have a simple random variable, a random sample, right? And either the sample size is large, meaning it's greater than 30, or the population is approximately normal. Okay? And when that sample size is small, we must check and determine whether the sample comes from a population that is approximately normal. So when we want to construct these confidence intervals, right, with that standard deviation unknown of that population, right, we will have to find out, number one, what does that sample mean? Still dealing with the sample mean, but beforehand we were dealing with the population standard deviation, but now we are going to deal with a sample standard deviation, right? If it is not given, we need to find those values. Step 2 is we need to find our degrees of freedom. That'll be the n minus 1. How many numbers are in our sample minus 1? And then we have to find that critical value. We find the critical value very similar to how we would find the critical value for a normal distribution, but it is very similar, okay? Where we'd still do alpha minus the CL. Oh, that's a bad pen to use. Okay, and then we compute the standard error. Standard error is still the same thing, but we deal with now the sample standard deviation divided by the square root of n. And then we multiply the critical value in the standard, we multiply the critical value and the standard error to obtain the margin of error. Remember, it's the same exact thing, but now we're just doing it in terms of our sample standard deviation versus our population standard deviation. So, we do it just like we did before, where we added and subtracted from the point estimate. Once we find our margin of error, we add and subtract it from the point estimate, and then we interpret our results. So, let's example 9. A sample of 123 people aged 18 to 22 reported the number of hours they spent on the internet in an average week. The sample mean is 8.20 hours with a sample standard deviation of 9.84 hours. Assume this is a simple random sample from a population of people aged 18 to 22 in the U.S. Construct a 95% confidence interval for the mean, the population mean number of hours per week spent on the internet by people aged 18 to 22 in the U.S. So, as normal, I tell you to write down the information that you know. So that's in step 1. Step 1, if we go back up and look at it, it tells us that we need to compute the sample mean and the sample standard deviation. And then from there, we're going to find our degrees of freedom and then find our critical value. So if we look at this, step one, right? Our information that we know is our sample mean is 8.2, right? And our sample standard deviation, we're doing a sample standard deviation now, is 9.84, right? Now the next part is we need to find our degrees of freedom, our DF. So that'll be n minus 1. So how many people do we have in our n? Our sample is of 123 people. So this should be 123 minus 1, which gives us 122. Now, if you read in our readings, right, since the number of degrees is above 100, we will use 100. And what I mean by in our reading is if we go to our table, our T-table here, right, and we look at our degrees of freedom are listed here on the left-hand side, and then our confidence levels are listed here in this table, then we would, of course, just like a Z-table, see where the two match. If you notice, we don't have a confidence interval of a degree of freedom of 200. So if we come relatively close to it with a 95 is this row right here, then we would say that we would use 9.84, okay? Now, if we did not have a T-table, all right, available to us, and we want to use some type of technology to find this critical value, well, we can also, and what I mean by the critical value is me coming back here for just 2 seconds. Let me show you exactly what I mean, right? Is when we're looking for this critical value, right? T of alpha over 2, right? We were normally doing 1 minus the confidence level divided by 2, right? So that'd be 1 minus 0.95 divided by 2, right? And we would typically type this into GeoGebra to find that z-score. So let me tell you, if we start in our probability in our GeoGebra Classic, right? Let me refresh our page from the beginning, okay? We always start in GeoGebra Classic and we go to probability. From probability, we are no longer dealing with a normal distribution. We are now dealing with a student t-distribution. So we will select student. Then we will select our degrees of freedom. So we just keep it in line with what we were doing is 100, right? Then we are going to select our greater than, and then we are going to enter in, you can enter in the entire 1 minus 0.95, because we're talking about 95 degrees of level of confidence, and then divide that by 2, right? And we end up with the exact number of 1.98397. Okay? And so that is the critical value that we need in order to move to our next step. 1.9, what was it, 9839? So we're just going to say it'll be 1.984. Okay? Now, we have our degrees of freedom, we have our critical value, and now we need our margin of error, right? Now, the margin of error is the exact same way that we were doing before when we were doing the other confidence intervals, right? And so we would now take our formula, right, which is We would take our critical value and multiply it by our standard error in order to get our answer. Okay? So we are going to take 1.984, multiply that by 9.84 divided by the square root of our 123. And then we will plug it in our calculator to find our margin of error. So again, 1.984, right, times 9.84 divided by, and I'm just going to put a parentheses just in case, parentheses, the square root of 123, close parentheses, and we get 1.76028. So our margin of error is 1.7603 when we round, and that's our margin of error. But we are constructing a confidence interval. So we take this margin of error and we add it and subtract it to our what? Our mean here. So our confidence interval will end up looking something very similar to saying 8.2 plus 1.7603 and 8.2 minus 1.7603. And when we add that together, we end up getting, this one will give us a 6.44, and this one will give us a 9.99, and Miss Parker just has it swapped around. So what does that mean? That means that we are 95% confident, right? That the mean number of hours per week spent on the internet by people age 18 to 22 is between 6.44 and 9.99. Okay, and that is our confidence level. All right, now let's hypothetically say that you are given a data set. And in this data set, we want to find our confidence interval and the degrees of freedom and the margin of error and the standard error. So now there's a couple of ways that we can do this. We can do it the long way and find out each individual piece of information, right? Now, I am going to teach you another GeoGebra way, all right? You should know both, but this video, I will go through the GeoGebra way of how to find this t-distribution information starting from scratch. We don't know what the mean is. We don't know what the standard deviation is. So let's just start from scratch. So we start with GeoGebra Classic. Okay. And starting from the GeoGebra Classic, we are now this time going to start with a spreadsheet. Right? I will paste my data into the spreadsheet, and we will select the row or the column where all of your information or data is in. Again, I typically like to start off with the one variable analysis here, and then it gives us a lovely histogram of the information, right? If I hit this summation sign with the X, it says show statistics. We hit the show statistics, and now we know that the mean, right, of this is what? 65.467, 4762, I'm sorry. We know that our number of values we have, our EN is 21. We know that our mean, our standard deviation and our sample standard deviation We have all of this here. Now you know what this S means. Now you know what this standard deviation means. You know where all of this information is. So if we go back to our question, all right, it says it wants us to find the following. We want to find the degrees of freedom. So that should be easy. We want to find the margin of error. We want to find the standard error, and we want to find the confidence interval. So from here, we can actually do one more extra detail. And let me blow it up one more time. In this drop-down statistics menu, we can actually select the t-estimate of a mean. So that means now we can actually select what confidence level we are at. We want to be at 95%, I do believe. Yes, we do. So we are now at 95% confidence level. And we can see that our lower confidence level is going to be at 63.9. Our upper confidence level is going to be at 67.03. Our margin of error is going to be at 1.5545. Our degrees of freedom is at 20. Our standard error is at 0.07452. And our mean is the same. So again, GeoGebra gives us a nice, sure way to see all of our information at one particular time. All right. So I think this will conclude my video for us today. Again, you should be very familiar with how to use GeoGebra, but in the same aspect of finding the confidence interval using a t-distribution or not, you should be very familiar on how to come to a t-table and find a value, or a z-table and find a value, and go from there. That's all that I have for you guys today. You be blessed.